Good morning to everyone present here. I am Sangeeta Lakshmi, working as Assistant Professor in RMK College of Engineering and Technology. Today we are going to see the session 3 of Unit 2, which is Mosfet Amplifier. So what are all the topics we are going to discuss today is biasing methods for Mosfet. Already we have discussed the first method, which is nothing but the biasing with feedback resistance. Actually, just you can recollect the previous session. Biasing means it is a process of giving the supply to the transistor in order to make it to operate in a desired region. So you know that for the MOSFET we are having three regions, that is cutoff, saturation and not saturation region. So out of these three, we have to make the MOSFET to operate in a saturation region in order to act as amplifier. So for that only we need some biasing methods. So last class we have seen the first method. Today we are going to see the second method, which is nothing but voltage divided biasing. The next biasing method is voltage divided biasing. Okay. So in this voltage divided biasing method, again I told you for the DC analysis, I told you we have to make all the capacitor to we have to open circuit, because I told you this coupling capacitor CC1 and CC2 both will be exhibiting the resistance, that is reactance equal to XC equal to 1 by 2 pi FC, right? So for DC analysis frequency is 0. So if it is 0, 1 by 0 is infinite. So infinite means this is open circuit because the current will not flow through the infinite resistance. So if we are removing both the capacitor, coupling capacitors 1 and 2, you will be having the circuit diagram. Here R1, then you have the resistor R2, here transistor, MOSFET transistor, here we have RD, here RS, this is VDD. Okay, so here we have ground. All the ground is connected together. So after removing this open circuiting this coupling capacitor, you have only this circuit, right? Only this circuit. And here also we have to open circuit this source capacitor. So you have only this RS. So now I told you, no, we have to apply KVL at the output side in order to draw the DC load line, right? So how to write the KVL equation here? KVL at the output. So if you are applying the KVL at the output side, you will be getting ID into RD, right? ID into RD, because the current flowing through the RD is ID. The current flowing through RS is IS. IS is approximately equivalent to ID only, right? So what is the voltage across here? This is the drain terminal. This is drain terminal. This is your source terminal, and it is nothing but the gate terminal. So the voltage across drain and source is nothing but the VDS. So here I have to write ID into RD plus VDS plus here the voltage drop across RS is nothing but the IS into RS. Instead of IS, I can substitute ID, right? Then here it is ground. Again, this VDD you are having, the circuit will be closing here, right? So you will be getting minus VDD equal to 0. So from this equation, I am grouping ID common outside, RD plus RS equal to VDD minus VDS. You can consider this is the first equation. So if you want to locate the point A in the DC load line, I have to substitute VDS equal to 0. So if I am substituting VDS equal to 0, I will get ID into RD plus RS equal to VDD, thereby ID equal to VDD by RD plus RS. This is the maximum current produced by the circuit, right? Similarly, you have to find the point B. How to find the point B? I told you we have to make ID equal to 0. If I'm making ID equal to 0 in equation 1, you will be getting what? ID equal to 0 means 0 equal to VDD minus VDS. Thereby, VDS equal to VDD. This VDS is the maximum voltage. Right? So, if you are drawing the DC load line, in x-axis you have the VDS, in y-axis we have the current ID. Okay, so in this, the point here it is A, here the point is B. So, A is nothing but the what? VDD by RD plus RS, that is ID max. B is nothing but the VDS max equal to VDD. So, after locating these 2 points, if you are drawing on straight line, this is nothing but the DC load line. Right? Similarly, how to locate the Q point? The same equation, one you have to take, the same equation you have to take. Right? So, if you want to locate the Q point, see here, if you want to locate the Q point, I told you Q point is nothing but the VDSQ as well as ID. Right? IDQ. So, how to find out ID? ID equal to what is the formula? It is general formula Kn into VGS minus VTN the whole square. This is a threshold voltage of the Mosfet transistor. VGS is the voltage between gate and source. So this is the VGS. The voltage between gate and source is VGS. So after finding out this ID, which is nothing but IDQ, you have to use the equation 1. From equation 1, you have to find out what is VDSQ. So VDSQ equal to what from this? You will be getting what? VDD minus ID into RD plus RS. Right? So that you can able to find out Q point. Clear everybody? I hope everyone understand this both biasing methods. So here we have analyzed amplifier only with respect to DC signal. And then we are going to move on to the small signal analysis. That is, we are going to analyze with respect to AC signal. That means your audio signal or video signal. Okay. Thank you.